In 1960, two men climbed into a metal sphere the size of a small car and descended into absolute darkness, 7 miles down. The pressure outside their vessel was 8 tons per square inch, enough to crush a human body into paste in milliseconds. Their mission? To reach a place on Earth where no human had ever been. A place we knew less about than the surface of the moon. When they finally touched bottom at 35,914 feet, they saw something that should have been impossible. Something that rewrote everything we thought we knew about life on this planet. What they discovered down there challenges our understanding of biology itself. And here's the terrifying part. We've only explored less than 1% of this alien world that covers more than half of our own planet. The Mariana Trench isn't just deep. It's so deep that if you dropped Mount Everest into it, the peak would still be more than a mile underwater. We're talking about 36,000 feet of water pressing down from above. At that depth, the pressure is over 1,000 times what you're experiencing right now. To put this in perspective, if you took a styrofoam cup down there, it would be compressed to the size of a thimble. A human body without protection would be crushed before you could even take your last breath. The pressure would collapse your lungs, crush your bones, and compact your organs into something unrecognizable. For centuries, scientists believed nothing could survive down there. The math was simple. No sunlight, near freezing temperatures, crushing pressure. It was a dead zone, an aquatic desert. The hostile environment was so extreme that life as we knew it couldn't exist. They were catastrophically wrong. But before we dive into what lives down there, you need to understand how this massive scar in the ocean floor even exists. Because the Mariana Trench isn't just a hole, it's a wound in the Earth's crust that's still being carved deeper every single day. The story begins 180 million years ago when the Pacific Plate formed. This massive slab of oceanic crust has been slowly moving westward ever since, and it's old. In geological terms, old means dense. Dense means heavy, and heavy means it sinks. On the western edge of the Pacific, this ancient plate collides with the younger, lighter Philippine plate. When two tectonic plates meet, one has to give way. The Pacific plate, being denser, gets forced underneath in a process called subduction. As it descends back into the Earth's mantle, it creates a trench, a deep, curved depression in the ocean floor. This isn't a gentle process. This is planetary-scale violence happening in slow motion. The Pacific plate is being dragged down into the mantle at about 2 to 3 inches per year. That grinding collision generates massive earthquakes. It creates volcanoes. It's why the entire Pacific Rim is called the Ring of Fire, a 25,000-mile horseshoe of seismic activity and volcanic eruptions. The Mariana Trench sits at the deepest point of this subduction zone, and it's getting deeper every year, every decade, every century. The Pacific Plate continues its descent into the Earth's interior, pulling the ocean floor down with it. The HMS Challenger first discovered this trench in 1875 during the first ever global marine research expedition. Using weighted ropes, they measured a depth of 26,850 feet in one location. They had found the deepest place on Earth, but they had no idea what was down there. They couldn't. The technology didn't exist. It would take another 85 years before humans could actually go there and see for themselves. Let me take you on a journey down through the layers of the ocean, because understanding what makes the Mariana Trench so extreme requires understanding everything you pass through to get there. You start at the surface, the sunlight zone. This is where 90% of all marine life exists. The water is warm, bright, and teeming with everything from plankton to whales. Photosynthesis happens here. This is the ocean we know. But drop down to 600 feet and the light starts to fade. You've entered the twilight zone. It's dim, cold, and strange. Bioluminescent creatures start appearing. Jellyfish that glow, fish that create their own light to hunt or avoid being hunted. Only about 1% of surface light reaches here. At 3,300 feet, you cross into the midnight zone. Total darkness. Zero light. The temperature drops to just above freezing. The pressure is already 100 times what it is at the surface. This is where you find anglerfish, those nightmarish creatures with bioluminescent lures dangling in front of their massive teeth. This is where giant squid hunt in the blackness, their eyes the size of dinner plates evolved to catch the faintest glimmers of bioluminescence. But you're not even halfway to the bottom yet. Keep descending. Past 13,000 feet, you enter the abyssal zone. The pressure here would crush a submarine like a soda can. The temperature hovers just above freezing, and yet life persists. Sea cucumbers crawl along the sediment, tube worms cluster around hydrothermal vents, volcanic cracks in the ocean floor that spew superheated mineral-rich water. These vents are biological gold mines. They're oases in a desert. Because here, in the absence of sunlight, life has found another way. Instead of photosynthesis, bacteria use chemosynthesis, converting the chemicals from the vents into energy. These bacteria form the base of an entire ecosystem that exists completely independent of the sun. But there's one more zone, the deepest of them all. At 20,000 feet, you enter the hadal zone, named after Hades, the Greek underworld. This is the realm of the trenches, and the Mariana Trench is its capital. When Jacques Picard and Don Walsh descended to the bottom of the Challenger Deep in 1960 inside the Trieste bathyscaphe, they spent only 20 minutes on the seafloor. 20 minutes in a place 7 miles below the surface where the pressure was crushing their vessel with 8 tons of force per square inch. And in those 20 minutes, they saw a flatfish, a creature that should not exist, swimming, living, thriving where science said nothing could. Since then, we've discovered an entire bizarre ecosystem down there. Amphipods the size of your hand, crustaceans that look like prehistoric insects, snailfish that are almost translucent, their bodies adapted to exist in a world of extreme pressure, sea pigs, bulbous pink creatures that waddle along the seafloor on leg-like appendages, feeding on whatever organic matter drifts down from above. We found single-celled organisms called xenophyophores that grow to the size of grapefruits, the largest single-celled organisms on Earth. We've discovered that life at these depths has evolved proteins and cellular structures we've never seen before, specifically designed to function under crushing pressure. There are creatures down there that glow in the darkness, communicating in ways we don't understand. There are bacteria that can survive in conditions that would sterilize most life on Earth. There are organisms that live at hydrothermal vents where the water temperature can exceed 700 degrees Fahrenheit, yet they thrive just inches away in near freezing water. Here's what keeps me up at night. We've only explored about 5% of the ocean floor. In the hadal zone specifically, the deepest trenches, we've identified only a few hundred species. Compare that to the millions of species we've cataloged on land. The Mariana Trench alone could contain thousands of species we've never seen. Creatures that have evolved in isolation for millions of years. Organisms with biochemistry unlike anything in our textbooks, and we've barely scratched the surface. Or rather barely scratched the bottom. Here's the part that should make you uncomfortable. Only 3 people have ever descended to the deepest point of the Mariana Trench. 3. More people have walked on the moon. More people have summited Mount Everest. We've sent rovers to Mars, probes to Jupiter, and telescopes that can see galaxies billions of light years away. But the deepest part of our own planet, we've visited it 3 times. Why? Because it's harder to get to than space. The pressure, the darkness, the sheer technical challenge of building something that won't implode under 8 tons per square inch, it makes spaceflight look easy. A spacecraft has to withstand 1 atmosphere of pressure difference. A deep-sea submersible has to withstand over 1,000. The deep ocean represents more than half of Earth's surface. It's the largest habitat on the planet, and it's virtually unexplored. We have better maps of Mars than we do of our own ocean floor. But here's why this matters beyond just curiosity. The deep ocean holds answers to some of humanity's biggest questions. How did life begin? How does life adapt to extreme environments? What's the limit of biological possibility? The organisms living in the Mariana Trench have evolved enzymes that function under extreme pressure and temperature. Enzymes that could revolutionize industrial processes, medicine, and biotechnology. We've already discovered antibiotics from deep-sea bacteria. We've found proteins that could lead to breakthroughs in cancer treatment. Every dive into the deep ocean reveals something that rewrites our biology textbooks, something that challenges what we thought was possible, something that expands our understanding of life itself. The Mariana Trench is waiting. 7 miles down, in crushing darkness and unbearable pressure, an entire world exists that we've barely glimpsed. A world that could hold the secrets to life's resilience, adaptation, and survival. A world that could teach us how life might exist on other planets, in other extreme environments across the universe. We've spent trillions exploring space. Maybe it's time we explored the alien world beneath our feet. If this made you see the ocean differently, if it made you realize how little we actually know about our own planet, hit that subscribe button. Because there are more mysteries down there waiting to be uncovered. And next time we're going even deeper into the bizarre and the unknown. The abyss is calling. The question is, are we ready to answer?